All right, so we're going to kick it off here. I apologize for the delay there, just doing some housekeeping tasks. But yes, so my name is Jonathan Spigler. I'm a principal architect with ClearShark. I've been working in the DoD sector in regards to IT for the last decade. And I've been with ClearShark for over half a decade now, which means I've actually worked with Palo Alto as a technology partner. We are actually, ClearShark is a value-added reseller of Palo Alto. We're also a consultant for Palo Alto, meaning that we work with customers to create solutions, which can include a variety of different solutions from Palo Alto's portfolio. One of them today we're going to be discussing is Prisma Cloud Compute. And we help customers kind of bring their solution or their need to fruition and work with them through the entire process. So today, the topic we're going to be looking at, which I'm sure a lot of you have heard the buzzword for or the concept for, is continuous ATO or CATO or CATO, if you want to be cool, making words out of acronyms. And I'm sure you've been in general briefings, or if you've been in solution briefings or vendors saying that this is continuous ATO. This is our solution. You buy a product, you have it. Well, we're going to be diving into, what is continuous ATO, how is it related to RMF, and then finally, we're going to be looking at Prisma Cloud Compute and how Prisma Cloud Compute isn't necessarily continuous ATO, but it can be a vital or critical tool in creating that holistic continuous ATO solution for your organization, right? So jumping into this, what are we trying to do? Well, bottom line is the faster we can conceive and develop and deploy applications in our DoD organizations, and this actually goes for not just DoD in general, but also federal, civilian, and commercial, obviously. But the faster we can develop, deploy applications to our organizations, the faster our warfighters are able to receive them, derive value from them, and more likely there's going to be a rapid mission success. But to achieve this, you need the technologies, you need the methodologies that align to this. So you can have a fast deployment methodology using agile frameworks, using DevOps, stuff like that. But being in a federal organization, being in DoD, you still have to adhere to a certain compliance, to certain controls, to certain regulations that are mandated by the federal government by law, right? So the focus today is how do we keep that speed, keep that agility, keep that rapid deployment, and still stay compliant. And not only just compliant, but is there a way we can even optimize the way we assess the compliance and vulnerability state of our systems, right? So continuous ATO, ATO is the authority to operate, and more or less is the approving process for IT systems within a federal organization. Is more or less the certification of a system owner, or it's a system owner must implement, certify, and they must maintain the appropriate security controls in order for their system to be launched in production, right? If they do not achieve that, if an authorizing officer does not say you have been granted to operate in a production environment, you cannot deploy it by law, right? And this is controlled, for the longest time, it was controlled by DIACAP, and there's probably some other stuff like around FIPS and around if you have a PII, so like PCI stuff or GDPR. There's a lot of controlling mechanisms, a lot of legislation that you have to adhere to. So now the new framework, or newish framework, which was released in 2013, is RMF, right? But there's two significant challenges that come into play whenever we're trying to achieve what was mentioned on the previous slide, and at the same time have this continuous, or have this state of authority to operate in our environment, have the authorization to have our application running. One of them is drift, right? Because a lot of the traditional ways this is being done is it's more or less establishing a point in time of the system, right? So developers go through the process of writing code, pushing out their app, standing it up, whether it be infrastructure and everything else. And then they have the accreditation done, and they know at that point in time on that day, it is compliant, it has the authorization to operate. But we know that in IT, a system does not stay the same. it is constantly changing. And the thing is, you want it to be constantly changing because you want feedback from your customers, you want feedback from warfighters or those who are supporting the warfighters. So you can update, fix bugs, fix vulnerabilities, and push out enhancements, features. So there's more integrations and there's more value derived, right? This creates drift, right? So then you have to go through the entire accreditation process again, and again, it can potentially, it does slow up the process, right? I've talked to some organizations where it takes them upwards of 18 months to get an ATO to deploy an application in their environment, right? Second problem is the ongoing ownership of the system, right? This, is in regard to contract turnover, the people that are working on it, especially whenever you have these complex systems that are comprised of multiple pieces. It's hard to track who owns what piece of the application, and also their authorization boundary, right? Just because you have 5 different disparate components that are like 5 different services or 5 different applications, whether they be on virtual servers or monoliths, or if they are in containers, they all could belong to a single holistic app. So how do we not only track the ownership but also the authorization boundary, right? So that's where cloud native technologies come in, and methodologies like DevSecOps can help us align to more of a continuous way to achieve our ATO, right? I'm sure you've heard the buzzword, which is shift left, which really means we can do our analysis from a compliance vulnerability perspective, code assessment, stuff like that, early in the build process of the application. And we can actually do that in an automated fashion using tools like Jenkins or GitLab or Travis, or there's a variety of different CI/CD pipeline tools out there. I mentioned Jenkins because that's usually the most popular, right? So we can do this analysis early on and produce artifacts that will actually help speed up this ATO process and not be so much a point in time, right? But more of a continuous look, and even a look ahead of what the system's going to look like if we push out an update, if we add a feature in, if we there's a new vulnerability that's released and we update it, what does the state of the application look like, right? So it allows us to continuously monitor our system for ATO, hence the continuous ATO. So I'm sure everyone is familiar with with RMF, or NIST risk management framework, and this is pretty much the standard underlying ATO methodology in DoD, right? And originally created to replace DIACAP, which DIACAP was more focused on a standard set of activities to certify and accredit a DoD IT system. And this would happen every 3 years. RMF takes a bit more of a dynamic approach, and it focuses on risk management, and its primary approach is the need to continuously monitor, right? Though it looks like it's almost a sequence of steps in here, which maybe for the first iteration it is, when you push out updates or you need to adjust a particular piece of the system, or if authorization boundaries change or something like that, you can more or less prepare and jump to one of these steps, right? RMF is supposed to not be so rigid and follow like a checklist of make sure that all root accounts are locked down, make sure that it's more of a framework that an organization can work within that sets up guidelines, right? Now there are special publications that help guide organizations as they work through this based on which step they are in the RMF process. But it allows an organization to be much more, I guess, freer in the way they approach their authorization. Move on to the next slide. So Prisma Cloud Compute. For those who have been working with the product a little bit longer, it originally was called Twistlock until Palo Alto acquired it, and it fell under the Prisma portfolio. And Prisma Cloud Compute Edition is the hosted. So let me start from the beginning. Prisma Cloud, it's a purpose-built platform, and it is originally it was purpose-built to secure your containerized, serverless, and now with the some updates to 2009, even your legacy host applications or traditional apps that are on your virtual servers or your monolith hosts, right? And it is to assess your vulnerability state, compliance state at every stage of the application lifecycle, right? So at build, at rest when it's in a repository, whether that be in a Docker image repository or a container image repository, or now with some recent updates to the product, you can actually just assess the raw code and the packages that are in it within a Git repository. So that's great. And also at the run stage. It is built to run within your existing cloud native architecture. So it will run within Kubernetes, OpenShift, VMware Tanzu, Brancher. So you don't have to erect new infrastructure to run this. It can run within. It runs as a container. It runs as a service on the host. It can be infinitely scalable horizontally. It is extremely flexible. It can reach into any environment. It can run isolated. It's constantly it can either pull down updates from Prisma Cloud Compute's intelligence stream directly from the internet, or you can sneaker net it over, because we know that there's plenty of isolated networks out there that cannot reach out to the network. So yeah, that is in a nutshell. And it's made of two components. One is the console, which is really the command control center, right? Where you define policy, you monitor, you create rules, stuff like that. And then there's your defenders. Defenders are actually the workhorses. They get deployed in your Kubernetes cluster or on your traditional hosts. And it is constantly polling the console and getting the policies that it needs to enforce. And I'm going to run over the features, a couple of the features real quick, because we definitely are quick on time or skinny on time here. So I'm going to, if we want to dive into these in more depth later, feel free to reach out and we can have a follow-up meeting. One of the features is vulnerability management. So you can assess common CVEs or CVEs from the broader CVE database that's on the internet, and also from Prisma Cloud's own database. And you can look for these vulnerabilities in your images, again, at build within your CI/CD pipeline. You can do it at rest within your container repositories. And you can also have this continue to be assessed at a run state, right? Same goes with compliance. So you can actually set up your compliance state. One of them is NIST SP 800-190, which is the containerized application, this special publication. So you can actually set up a compliance baseline, again, assessing at build, at rest, and at run. And this can also go for your traditional host or your legacy host. Runtime defense, again, the same, those same vulnerability and compliance capabilities will carry over into your run state. So when you deploy these container images, or whenever you deploy your traditional apps, you can still be constantly assessing the vulnerabilities, known vulnerabilities on these applications, whatever state they're in. And also it allows you to do forensics. So if there is a rogue process that starts up, or if a file gets modified, or if anything anomalous happens, Prisma Cloud is able to detect and actually give you insight into what processes were spun up prior and post, any network connections that happen, any file modifications. So pretty much be able to give you a full forensic analysis of if an event happens, if an incident happens, which will be alerted within the Prisma Cloud console. You can track to all events leading up to and after. So detect lateral movement, detect stuff like support scanning, again, like rogue processes. And whenever you don't have to necessarily, so if you're familiar with containers, you don't have to delete the container or stop the container altogether. You can actually do selective process killing. I forget the actual term as far as feature goes, but it gives you the ability to have the option of alert, kill the container altogether, so it'll just spin up a new one if you're like in OpenShift or Kubernetes, or stop that particular process from running. And the great thing is, when you deploy your containers, it'll actually watch those containers, and it will actually create a model behavior that what it expects over the next 24 hours. This is how this container should act. And so you don't have to create some guessing policy that, okay, this is what I think it's supposed to do, right? It'll actually create this baseline model for you. And then if it deviates from that, you can actually then enforce and, again, stop the container, kill the process, stuff like that. So you don't have to go through a lot of guesswork of what should my runtime policy look like. Access control, again, controlling RBAC within your Kubernetes environment. You can actually monitor and instead of having to dig into, if anybody's ever had to manage OpenShift or Kubernetes, any type of Kubernetes distro, it can become an administrative nightmare to track down the proper RBAC or what RBAC controls exist. This gives you the ability to actually have that insight right within Prisma Cloud. Cloud native firewalling, this is really sweet, I think. It just gives a lot of flexibility for your standard 5-tuple protection as, at a container level. So within the actual Kubernetes cluster itself, you can actually restrict ports. So any type of east-west traffic that happens within your cluster, and for those who are familiar with Kubernetes, know that there's an SDN overlay. It's not exposed to the quote-unquote external or the standard network that's around it. And we're always getting the question: how do we block traffic in there, or how do we see traffic? How do we get notified that there's unauthorized traffic? Prisma Cloud can do that, right? So not only can it do it from a layer 4 perspective and just do your standard 5-tuple, port, protocol, IP, source destination rules, but you can also enforce layer 7 firewalling. So the feature which was originally called the Cloud Native App Firewall now is called the Web Application API Security feature, and it more or less is a web application firewall, right? So you can actually have a web application firewall that is malleable and flexible and is deployed, with your defenders, right? And you can protect from top 10 OWASP. So stuff like shell shock, brute force attack, SQL injection, evasion techniques, stuff like that. You can deploy this right beside your containers, and it's not as a sidecar. If you want to do some more reading on how the Defender architecture works, right? So you don't have to deploy additional infrastructure to achieve a WAF protection to protect from those top 10 OWASPs. And I apologize for the crying in the background. It's my 2-month-old. The pleasures of working at home. So yeah, that is another feature. Next feature, next slide? Oh wait, CI/CD integration. There is a plugin, there's a Jenkins plugin and a couple other plugins, but the one I'm going to mention is Jenkins, but it gives you the ability to build these compliance and vulnerability assessments right into your pipeline. So before you're even able to push to a repository or even deploy a container image, you can have your images assessed by Prisma Cloud before they're even available for deployment, right? So your developers get that early notification or early knowledge of a compliance adherence or deviating from a compliance adherence or a new vulnerability that was released. Maybe they're including a new feature that includes a new Node.js package and introduce a vulnerable, like you're going to see later in our demo, like a Constantinople package. They can remediate this even before it gets launched into their actual dev run environment or their test run environment. So you can do this with the Jenkins plugin, or you can do it with the Twist CLI binary that is included with Prisma Cloud. So you can do your just like some standard script logic and stuff like that, and have your newly built container assessed that way. And then last point I want to make, or last feature, I guess you call it feature for Prisma Cloud, is, and doesn't directly say it, says it here on the first bullet, but is their ability to be extremely kind of flexible, extensible, and versatile when it comes to how you interact with the platform. So obviously you can log into the console and interact with the GUI through that, and I do that every single day, or everything that is done within the console is API driven. That API is exposed and accessible and is very well documented as far as what it can do. So you can pretty much do anything that you can do in the GUI, you can do programmatically via the API. Why does that matter? Well, it provides almost an unlimitless potential for you to write your own logic, write your own business logic, to pull information, to start to enforce certain policies or vulnerability or compliance policies, to tag certain CVEs, to pull information on certain collections, which you'll see what a collection is here a little bit later. And if we go back to this, starting with the topic of continuous ATO, it gives you the ability to use the information that is gathered through the analysis that Prisma Cloud does. You can retrieve it and then back it into whatever format that is relevant to your organization, right? Whether it be a POAM spreadsheet or maybe some other type of information repository or data repository such as Splunk or Elk or something like that, and be able to use that in your accreditation process. So you don't have to go into the GUI to do this, or even to pull this information, or to even get certain actions to happen. You can do it all through the API, which is actually driving a couple of the features we'll see later, or a couple of the functions we'll see later in the demo. So how are we trying to help customers define and apply and maintain a continuous ATO? Again, we're going to be using RMF. Again, we're not trying to necessarily automate the RMF process. You can't do that, right? Because RMF is at 3 high levels, right? You're at the organizational level, the mission level, and then finally the system level. We're trying to optimize and I guess have the system level, the accreditations and controls, or sorry, the controls that happen at a system level more or less be assessed and automated in the most efficient fashion, right? That's what we're trying to do with Prisma Cloud. We're trying to use the features that are in there to, anytime a new feature or a new release goes out, your developers don't have to wait for that assessment to be done. It will be done right in their pipeline. So they know without even having to have their security engineer be involved, or anybody that's responsible from the security aspect of the system. They don't need them to be present. They can go and develop, and they know the problem exists, and they can remediate it before they actually get to the step of, hey, we need to bring our AO back and we need to get this reauthorized, if there's a reauthorization that's in process, right? So we're trying to use different aspects of Prisma Cloud to do that, such as collections, which we'll see what collections are later, such as tags, associated vulnerabilities, creating authorization boundaries, stuff like that. And it goes to this whole idea of, DevSecOps is a lexicon, right? It's a collection. It's a collection of definitions. It's a collection of thoughts and units, right? There's no one correct way of doing it. We're trying to provide a concept, obviously a bunch of features, but back it into a more of a broader conceptual idea that can help speed up certain parts of the RMF process. So we're going to walk through each step of the RMF process, and those of you that are familiar with the RMF process will know through your experience, what you have to go through, what special publications you have to adhere to at each one of these steps, based off of the type of system it is, based off the information, based off of, a variety of different, elements, right? What I'm going to do is just at a high level, what the step is supposed to be related to, or what the step is you're supposed to be doing the step. And then what we're going to be doing if we're in an organization deploying Prisma Cloud, what we would be doing from a Prisma Cloud compute perspective, right? So the prepare step. So the purpose of the prepare step is essentially carry out all essential activities at the 3 risk management levels, right? So at your organization level, at your mission level, finally at your system level. So that's going to include stuff like assigning management roles, creating your risk management strategy, which a lot of this should already be done at an organizational level. This should already kind of be established. What we'd be focusing more on is the tasks that are at a mission level, at a mission level, at a system level, such as establishing what the mission or business focus is, who the system stakeholders are, asset identification, so stuff that's going to be participating in this broader system, establishing what your authorization boundary is, what information types are included in the system, who your enterprise architect is, stuff like that, right? So upon establishing that, what you would be doing from a Prisma Cloud Compute perspective is you would first be deploying your infrastructure, right? You'd be you would be deploying your Prisma Cloud Compute environment, right? And making sure wherever you deploy it, it is able to access whatever artifacts or container images or anything that it needs to, where it needs to do an assessment or analysis of code or a container or even or a host that is able to access it, right? So this could be in a couple of different networks. It could be one network where you have a way to create multiple consoles, and you can actually create what's called subordinate consoles, and you can have a very kind of like, scaled out horizontal architecture that reaches into multiple environments, but more or less you would be deploying Prisma Cloud compute. On top of that, hopefully aligning to the step from a organization, mission, and system level, which is establishing system stakeholders, asset identification, stuff like that, giving names to the actual system, you'd be creating a collection of labels. These labels now, instead of just being in a document, a Word document, PDF document, Excel spreadsheet, or whatever, you can actually put these labels within your container image. And by doing that, by following a good label hygiene process, meaning you're deriving these values from the actual RMF process itself, you are now actually more or less operationalizing these values, right? And you're associating with your containers. You can use, and you'll see later, you can use these labels later down the road to attach and enforce policy. So making these what were originally just kind of logical and just more or less representative values to the system from a documentation perspective, you can now use them to enforce policy within Prisma Cloud. So you can include these, and then you see a couple examples in here. You can include these values, these labels within your actual container image. So step 2 is categorize. And the purpose of categorization is to more or less determine the impact if there's a loss of confidentiality, integrity, and availability of that system, right? So the information that's in it, stuff like that, right? So it's important here because when we do this, this will help define or start identifying what controls we need to assign. And also when we're creating our authorization boundaries, this will also help us create our authorization boundaries are going to be attached to what's called collections, right? Which is going to be a group of images or containers that fall under the same ATO, right? So here's an example of when we categorize our systems and then we associate them to an authorization boundary, we can actually represent that in Prisma Cloud via a collection. So you can see here, we have a collection called ATO 2020-0601-1. On the left, we have a unfiltered look at Prisma Cloud's radar view, right? And it's the entire Kubernetes environment with a couple other Docker hosts in there. There's a lot of information, and it's not really drilled down or filtered to show pertinent information for whoever's involved in assessing what the vulnerability or compliance state is of the system, and then the containers making it up, right? On the right, we can see that we have filtered down to just show the collection of ATO 2020-0601, and it shows a couple, and it shows an Nginx ingress controller. It shows a Splunk server. It shows a Struts container, a Struts container, and this is all under one authorization boundary, right? When we're working through the RMF process and when we're constructing these systems, it's not always just a, back in the day, it would just be single server, single application, single service, and then that'd be its ATO, that'd be its authorization boundary, right? Now with cloud native compute workloads, an application could be made up of multiple container images spread across multiple nodes within a Kubernetes cluster, or even across geographical locations, right? But it's still the same system, same application. But how do we group them all together? This is a way we can, and then also assess its compliance and vulnerability state. This is the way we can do that. All right, so next step is to select. So selecting the controls that are relevant to your system, right? So you select, tailor, document the controls that are necessary to protect this system, right? You do the same too in Prisma Cloud, right? So there's a variety of controls, right? If we're not worried about HIPAA compliance, well, don't include that within your policy. If you're not worried about um, GDPR, don't include that within your compliance policy, right? Upon doing that, upon selecting that, what we're able to do, again, going back to the API, we can actually export, after we do initial analysis, we can actually export all compliance and vulnerability findings, and then we can start assigning tags, which actually rolls into the next step, which you'll see here in a second, which is implement, right? From an implementation stage, the whole purpose of the implementation is to more or less take the previously selected controls, right, in the select stage or the select step, and then we're actually going to enforce that. So upon enforcing, we'll actually get results back, and we're going to see what the current state of our containers are, right, or our system or application. We can then use what's called tags within Prisma Cloud to actually create exceptions and more or less provide more context to the ATO status of the system. And these tags aren't just there for arbitrary values, for just annotations and just statuses. You can actually use these tags to create policy exceptions, right? So more or less create these gated controls, which I don't like using gated because everyone thinks, okay, we just went from doing DevOps and DevSecOps and we're back to waterfall. The best thing I can think of is gated, but more or less create an enforceable yet flexible way to allow your developers to know they're in a vulnerable state with their application, to know that they are not adhering to the compliance controls that you're setting, but not to stop them from working through the problem. You have to give your developers a chance to fix their code, to fix the vulnerabilities in their code, which we'll see later in our example, right? But you can set enforceable time. You can set a milestone time. You can say, hey, we're going to give a week for for high findings, for high vulnerability findings, high CVEs. And after that week, you're not going to be able to deploy in our test environment. And then for the production environment, we're not going to allow you to deploy any workload that's going to have anything above a low finding, right? From a Prisma Cloud perspective. The next step is, all right, so you can see that actually in process here. So this is on the left is the Prisma Cloud console. We can see that we are alerting and blocking from low to high, or sorry, from low to critical. And at the bottom here, we actually have conditions. We have exceptions here. More or less allowing any CVE that is tagged with this exception, such as ATO 2020-0601, and then it's like -1-M, and then has something else. Any CVE that has that, all we're going to do, we're going to ignore, right? Or you can alert. I would prefer, it'd probably be preferable if you alert. And then at least the developer knows that, hey, this exists, fix it, right? Instead of just stopping dead in the water. So, and you can apply these, again, not just at rest, analysis at rest, but you can apply this at build, you can apply this at deploy, and also runtime phases, right? So this type of policy is applicable at all stages of the life cycle of your application, right? So kind of jumping ahead a little bit, but the assess stage. So the controls that have been enforced or that have been implemented, are they being implemented correctly? Are you improving? Are the developers improving, right? Within Prisma Cloud, everything is represented in the form of a heat map, right? So the darker the shade of red, the worse you're doing from a vulnerability compliance perspective, right? So if we see here, we can see that, well, this is actually to show a couple of different things. One, to show that there's a lot of different workloads or a lot of different containers running out there that are in a not so compliant or in a vulnerable state. It looks like this is the vulnerability panel here. But what we can do, again, is we can filter down to the authorization boundary that is relevant to us, right? And that's represented in the form of a collection. So you can see we go from having all of these different workloads at the top, and then we can actually filter down, and show only the workloads or the containers that are relevant to our accreditation, right? So again, we're able to then assess, see where these workloads are, and this could be, again, at the build phase of our system development. And we can see the more or less improvement as we work through this, as we work through the steps, and we continue, and more or less just continuously go through that, right? We're going to probably be spending a lot of time in the select, implement, and assess part of this, right? So, because we're constantly, the developers are going to be constantly improving and enhancing and fixing their code, fixing vulnerabilities. Finally, we're going to get to the authorized step, right? And the authorized step, again, the authorizing officer will deem the system suitable to be deployed in production, right? So obviously there's a lot of other things that go on here, but at a system level, at a technical level, we can actually use Prisma Cloud's information, the information gathered from it, to compose certain artifacts in the authorization step, right? So we can actually, since the API allows you to export this data into whatever fashion or form you choose, you can actually use that to maybe even speed up the documentation creation process or step. So you can more or less provide that as dynamically and as flexibly as possible, right? And then the last step, which is kind of completing the circle here, is the monitoring task, right? The monitoring task is to continuously assess the more or less maintain ongoing situational awareness about the security of the system, if privacy is of concern because you have PII in there, whatever the privacy state is of the system, and more or less if a vulnerability or a new control pops up that the system components need to adhere to, have more or less situational awareness so that you can make decisions to update your code or fix whatever needs being fixed, right? From a Prisma Cloud perspective, your containers are constantly being assessed. They're constantly being assessed against these policies, right? They're constantly being evaluated from a vulnerability compliance state. And also, is there malware? Is one of the running containers get pwned, and now they're starting to do a port scan across your Kubernetes cluster? This is all being monitored, right? And as new CVEs are released, these are also being enforced or also being used to look to see if these exist within your environment, right? And the cool thing is you can actually create, exceptions or grace periods. So if a new CVE comes out within the, nationwide CVE database or from Prisma Cloud, you can actually give a grace period of X amount of time for your developers to fix that, right? But it gives you the ability, or going back to sticking with the theme of continuously monitor, our developers want to constantly push out updates, enhancements, and new features, right? This gives them the ability to look ahead in time to see that, okay, in our build phase, let's say release, 1.2 of our continuous ATO app. In 1.2, we want to introduce a package or Node.js package called Jade. If we do that, what does our vulnerability state look like? What does our compliance state look like? If we were to release this in production, right? We're going to get that information as early in the build process as possible, so it doesn't become a problem when we reach production, right? We can assess and fix it, and not only fix it from a security perspective, but if it does cause any issues with the functionality of the app itself, we can actually address that early on rather than have it a fact known afterwards, right? Okay, so I'm going a little bit over time, so I'm going to speed up this, and then we're going to jump right into the demo. So for the demo, this is kind of the logical, 10,000 foot view of it. We have a developer that's going to be working within their integrated development environment. For mine, it's going to be Atom. I'm going to be working on a Node.js app that also includes a MySQL portion, but we're going to be focused just on the Node.js portion for right now. I'm going to push release 0.1.0 to my SCM, which is GitHub. This will actually create or invoke a webhook. The webhook will reach to my Jenkins server, my Jenkins server has a pipeline set up to actually pull this repository. So it's more or less watching this repository, and if it sees a change that's invoked by a webhook, it will then do a git pull and pull down this entire Git repo. The pipeline then will look at the included Jenkins file that's within this repo, and it'll actually initiate the pipeline. Very first step is to test the environment to make sure that all dependent executables, binaries, anything that is needed to run my environment, I have that checked right at the very beginning. It will then build the image, right? So it's going to take the code that's in there and it will actually do a Docker build. And after it builds the image, assuming that it's successful, it'll actually scan it. This is going to be done with the Jenkins Prisma Cloud plugin. So it'll actually reach out to the console and it will pull down, or it will check what policy should be enforced based off of certain characteristics we associate with it. The characteristics in this are actually going to be driven, if you remember, all the way back to the beginning of, well, not all the way back, but about midway through the presentation, the labels that are actually going to define what the ATO is for this, right? So it will actually associate the policy based off of the labels that are included. And you can use other attributes to define that also. Afterwards, it's going to scan and it's going to report its finding. My policy right now is only set to alert for my build phase. So anything that's in my continuous integration pipeline is only going to alert at this point. So we're going to allow our developers to move through this, even if there's critical findings, right? But they can't push to test or production. You'll see here in a second. So it's going to report findings back to the console. A couple artifacts that it's going to spin off, and this is the great thing about having that open API. It's going to create a POAM. Now, the POAM probably isn't the best representation of what you would see in a real world situation. I just wanted to more or less demonstrate the fact that you can in fact have this information exported into whatever format is most relevant to your organization. In this case, we're actually going to be exporting a POAM spreadsheet that's going to have the findings in there, and you can actually use that in your authorization process, right? Last step is going to be clean up the environment, right? We're going to remove that build of the Docker container so our Jenkins server doesn't get all fat and bloated and stuff. And then it's going to more or less report those findings back to developer within the Jenkins console. Once we have deemed that the code is ready to be deployed into the test environment, and you can see here in the top right-hand corner, we have our auditors that are saying anything that is a critical finding is going to be blocked. I don't care if it's in your test environment or production, especially in production, we are not going to allow it. High, we're going to allow 1 week. We're going to allow you 1 week to resolve that. Afterwards, your containers will no longer be able to run. Medium, 1 month. Low, we're just going to constantly just report on it and strongly recommend that you remediate it. So what this does is allows our developers to, we're going to try and push it with a critical finding. It's not going to work. And then finally, we're going to go back, fix that, push it into our test environment, and we'll see the fix, how it allows it. But what we're able to do is use tags to enforce these policies, tags and collections to enforce these policies, and associate them to particular CVEs, right? You'll see what I mean here in a second. So let me exit out of this. And it looks like, so I know we started about 10 minutes late. Hopefully we can go about 10 minutes over. We're about 42 minutes into the presentation. So I got 18 minutes for the demo, and hopefully I can get this done in about 15 minutes. And then we have about 3 minutes for Q&A. All right, so let me bring up so this is my text editor, Atom. So ATOM, it's free to download if you're interested in using this. I think it's pretty sweet. It's lightweight. It's not super, super heavy. And there's a lot of packages and add-ons that you can add on there. One of them being Git, which we'll see here in a second. And then we have our different environments. Let me move this to the bottom. There we go. So we have our Jenkins environment. Let me log into this. We have our Docker Hub. This is where we're going to be storing our built container image. Now, it doesn't have to be, your environment doesn't have to be Docker Hub. Prisma Cloud is extremely flexible when it comes to what container repository it's pulling its images from whenever it's doing any type of assessment. You can use stuff like Nexus 3 or AWS's container repository, or pretty much anything that adheres to Docker version 2. that's also covered in the documentation if you're interested in that. Here's my Prisma Cloud console. Let me log into this real quick. Here's my OpenShift console, and I'm running OpenShift 3.11. For those of you that are running on 4.6, please don't make fun of me. I'm going to be upgrading here soon or moving everything over to that soon. And then we have my GitHub repository, right? This is where all of my code, all of my Jenkins file, my Docker build, or my Docker file, everything is going to be stored in here, right? So this is where my single source of truth is being stored. And okay, so before we actually launch our pipeline, I want to touch base on a couple different pieces that I mentioned in the presentation so everyone knows where I'm coming from. First is collections. So the collection that we're going to be associating all of our container images to is this one right here, ATO package, CATO 12.03.2020, right? And what it's going to be doing is looking for any images that are in the build process or that are deployed or in a repository at rest. It's going to be looking for the label ATO package : CATO 12.03.2020, right? But you can see there's a bunch of different other ways you can create these collections, and this is how you can create your authorization boundary. Let's go to tags. Here we have tags. Again, tags are not just arbitrary values to annotate and mark up certain CVEs or whatever. You can actually drive action with these. You can actually drive policy with these. So we have three of them. One is the CATO Node.js poem high finding, one for low finding, and one for medium finding. And what we're going to do is actually use those values, use those tags to help define our policy. You can see we're going to be focusing on vulnerabilities this round, not so much compliance, but vulnerabilities. So we go underneath images and we go underneath deployed and we look at our policy here. So our policy is CATO-test. So this is a policy sculpted up to address containers that are being deployed in our test environment. So we can see that we're focused just on our CATO-test environment. So the namespace that's in our OpenShift environment for just CATO test and any deployments that have this value. So labels don't necessarily only have to be for Docker images. You can also apply labels to your deployments. So those that are familiar with Kubernetes and OpenShift, you can actually create key value pair labels in those deployment artifacts, right? You can then use those values to actually enforce policy, right? So more or less, and we have then a catch-all, a universal block at the end. So these are the only two kind of like user deployment environments that you can go to, either CATO prod or CATO test. If anybody tries to deploy outside of it, RBAC with an OpenShift perspective will stop it. You can actually get even more enforcing use Prisma Cloud. But what this does is only container images and deployments that have this label will actually be allowed to deploy, even if they have, you know, a finding, a vulnerability finding of the severity. Because what we do down here is we create exceptions based off of those tags. I don't know if you can see that, but we have ATO package, CATO Node.js, poem high finding, right? And what we're doing is we're only going to alert, even though our policy clearly states that we are going to block any high finding. But if the CVE is tagged with this, and you'll see what I mean by that in a second, we're actually going to allow a grace period of 1 week, after which we're then going to block, right? We're no longer going to alert. Same goes for medium, but we're going to allow a month. And then for our low findings, we're actually going to we're just going to alert on that. Again, what this does is allows our developers to remediate and fix their problems or fix their vulnerabilities early on in their development process rather than waiting to the very last moment. Okay, enough talking. Let's actually launch this real quick. So all I'm going to do to invoke the webhook, I just need to modify a single file here real quick. So we're just going to be update this README file, and what this will do, it will push up to my GitHub repo, and we can start the entire build process. So we're going to, here a little hotkey, we're going to add, we're going to commit, and we're going to push, right? All right, initial push, save it. As long as it doesn't flake out on the SSH key, we should be good. All right, let's pivot over to our Jenkins console, and we should see, yep, build 18 is starting up here. So again, for those that aren't familiar with webhooks and Jenkins and everything, just know that a developer won't necessarily have to, there's ways to automate these manual tasks, such as testing out code, such as storing stuff within your SCM or your source control manager, and also doing builds such as this, compiling it, building your code. And you can do that, such as I just did right there, using webhooks, and then a webhook will actually then instantiate your actual pipeline within Jenkins, right? So build 18 is done, right? And you can see I've done a couple different builds. If I refresh my screen, we can see that we have a couple artifacts, or well, one artifact. You can see I've done a couple builds since then. But one of them is this POAM spreadsheet, right? And this is actually derived from values within Prisma Cloud. So let's open that up real quick. Hopefully it's not going to take a while. I just rebuilt my Mac, and it may take a second to bring that up. There we go. So we can actually take values from Prisma Cloud, and we can actually populate our POAM, right? And this is going to be every single build, right? So as our compliance and vulnerability state of our system or our application improves, we can actually have our POAM spreadsheet represent that, right? So pivot back to here. Let's look at our 18th build, which is the latest one we just invoked, and let's look at the vulnerabilities of it. So if you remember back to our hypothetical policy, we're allowed, as long as we are tagged with the appropriate values and or labels within our container images, certain high and medium CVEs can actually pass through. And this would actually be allowed via your security team, via whoever your security engineer is, right? They would actually be able to do the tagging for you and say, okay, hey, this particular CVE, we're going to allow a week or whatever, right? But if you remember, the policy was any critical finding will not be allowed to be deployed, right? So in order for us to actually move on to the next step and actually deploy this image within our OpenShift environment, in our test environment, this critical finding has to be remediated. So that's build 18. And sorry, let me actually go back to that real quick. So what is the actual finding here? So we go back to image vulnerabilities. We can see that it's actually a package called Constantinople, and it's actually the version 3.0.2. And we can see the actual fix, of which this is all provided by Prisma Cloud, says the fix actually comes in any version 3.1.1 or later, right? And if we actually go to our Prisma Cloud console, we'll actually see the same exact thing under vulnerabilities, images, and we go to CI for continuous integration. And if you remember back to the power of using collections, we can filter the noise out, and we can only show the ATO package or the authorization boundary that is relevant to us. We see our latest build 18, and we'll see the same information. We see that there was a critical finding, Constantinople, and this is what we need to fix, right? So let's say that a developer isn't aware of this. Maybe maybe they didn't get the memo that that's what you have to do to be able to move on. So let's try actually deploy that app real quick. So within my actual code repository, I actually have a couple OpenShift files, and one of them you can see on the left here is a deployment. So I can actually go in here. I'm going to update this to build 18. We're going to save it, and we're going to try and deploy this. So I'm actually already logged into my OpenShift environment. So go OC, get pods, make sure there's nothing running. All right, there are no pods running right now. So let's do this OC apply F Node.js, and we're actually going to deploy that. So let's take a look, and I'm sorry for the panning around here. There's a lot of moving pieces to this. Let's take a look at the pods that we're deploying, and we can see that there are runtime errors for each of these. Why is that? Well, we're not following policy. We can see it right here in the logs that there was a CVE package with a severity such and such, and it actually calls out that Constantinople. So we are not allowed to deploy this because we have a critical finding, right? So if a developer wasn't even aware of this, or they tried pushing this, they would not be allowed. They have to fix that before they move on. Now, this is just one way of doing it. There's a variety of different, whatever adheres or works best for your organization, you can cater that approach. This is just to show an example of it. But you can see here, we can enforce those policies that are spoken and talked about in rooms, and we can actually integrate that into our system, into our assessment. So let's go back and let's fix it. Now, we're going to get a little Node.js-y here whenever I try and fix it. And you don't have to completely follow along. Just know that what I'm doing here is if a Node.js developer were to fix this, this is probably the steps that they would take. So first thing is we're going to go to our app level. So we're going to go to our Node.js directory, and we're actually just going to build it out right here. So npm install. And what this will do, it'll actually build, and you'll see all the modules that are included for this Node.js app. On the left here, we can see that. And we can actually see the Constantinople module that's in question, right? If we look at the actual package, we can see that it is, in fact, the version that is below 3.1.1, so it's 3.0.2. In order to fix this, we need to specify a couple things. One, in our package.json, we actually need to, and I'm going to copy and paste this from my notes so I don't get it wrong, we actually need to say, hey, one of the dependencies in here is Constantinople. But we're going to allow, with using this little caret sign, you're allowed upgrading to the latest minor release and patch for 3. Whatever, right? For major version 3, you can go up to as high as you want. So let's give that a try real quick and see what happens. Push updated Constantinople. Save it. Pushing. Okay. Now let's go back to our build. This should have initiated another build. We can see build 19 has started. And thank you. It looks like we had a couple of people drop. I appreciate everyone else that has stayed on. I know I'm running over a little bit. 5 more minutes and we should be done. And hopefully we have for some time for some Q&A. All right. And you can see each stage. I didn't really talk about the pipeline you see here, but it's relatively self-explanatory. Checks out the actual Git repo. It tests to make sure PowerShell is there because that's how we create some of our artifacts. It actually builds a Node.js image. It then scans it with Prisma Cloud. It publishes the results back to Prisma Cloud. It creates a collection query using the PowerShell script. It then exports that POAM also. The POAM exporter is actually in Python. It then deploys the image, meaning it pushes it to Docker Hub, removes it, and then cleans everything else up and creates these artifacts we see above, right? Okay, let's look at build 19. Look at the image vulnerabilities. It's still there. What's going on? Well, again, if you're not totally familiar with Node.js, know that you can have even nested dependencies. And there's a lot of really cool ways of resolving this. Before I do that real quick, I just want to once again go back here and show how we can dig further into this finding. So if we go into here, layers, we can actually look at the different layers of our container and identify where this vulnerability actually sits. We see it's in this copy image, and what we can actually do is go back to this this layer of the image and find out what actually is causing that. So it gives your developers a much more effective way of diving deeper to figure out what's going on. I can see people are dropping by the seconds here, so I'm going to try and hurry this up. So to fix this, there's actually another package in here called Jade that also relies on Constantinople, and we need to actually patch that. So to do that, I have all the steps here. We're actually going to do this, npm update force. So before we do that, we're going to actually do an npm audit. And you can see here in the Jade application, for this one right here, that this particular version of Jade has a vulnerable Constantinople version, right? So to fix that from an npm perspective, you can actually go npm audit fix force. And we'll have to do this one more time because we can see there's still vulnerabilities around. And I only know this because I've already ran through this a couple times. But this is more or less what your developers would be doing. So we can see now, if I clear that and I do an npm audit, I can see now Vulnerability is low, 3 low, 1 critical. Oh, last thing I need to do. I also need to, I did include that. Package.json, Constantinople. Audit fixed force. And I believe that is everything I need to do. Nope, it's still there. There we go. That should have done it right there. Beautiful. All right. Now that we've updated all that, let's do our final push. At least to get into test. Commit push. All right. Fixed Constantinople version along with other things, right? Other things. Not the best way. I'd probably get yelled at if I was working with a broader group, but you know, whatever. All right, saved, it's pushed. Should initiate our final build here. We'll see build 20 pop up here in a second. There we go, build 20 has instantiated. And we're at the 1 hour mark. I apologize for running over a little bit. All right, and let's go look at this build real quick. Image vulnerabilities, and we can see now that severe or critical severity finding has gone away. It is no longer there. If we look at our actual console here, we can see that it's also gone, well, along with a couple other things that was fixed when we did our NPM audit fix. And make sure my vulnerability policy is set up correctly. Cool. Now let me go back here. So when we want to actually provide a way to exclude or create exceptions here, let's go into deployed images. Here, product. So here we can see we have a couple tags that are associated with particular CVEs. If you remember those tags that I showed a little while ago, this is where we can actually create those tags. We can actually even annotate, fix them 1 week, right? This is all, you know, if you want to provide context to it. But what we can do, anything that has that packet or that tag of ATO package, CATO Node.js POAM, high finding. I also have done it with this one, and I've also done it with this high finding. And I've also associated this medium finding with that, with this medium tag. What this does is, even though our policy for our test environment states you cannot deploy workloads or deploy containers that have any medium, high, or critical findings, we do have those exceptions for 1 week, allowing our developers to deploy this in their test environment so that they can remediate those and still kind of move forward with developing their code. So if we remember, what was the build number? We were at build 20. So if we go back to our OpenShift, deployment file, let's update that to 20, save it. And there's probably an automated way of me doing this, but I thought it was, you know, maybe easier to follow going that way, because you can actually automate this portion of it too, so it gets deployed. I just haven't built that into my demo yet. And we'll go OC apply F Node.js. All right, that has been applied. Let's go to our pods, and we can see now that our containers are being created because they are adhering to policy, right? And we'll see that there was a replica count of 3. Those will spin up. And then we can pivot over to our radar and actually look at our container workloads. And we can see that there are 2 running right now, and soon enough, there will be 3. I apologize for the